Today we are going to start our first special parallelogram, which is going to be a rhombus. A rhombus is a parallelogram with 4 congruent sides, so I'm going to use tick marks to show that all 4 sides are congruent. Because it is a parallelogram, we know that opposite sides are parallel. I'm going to use my arrows to show that the opposite sides are parallel. We know that opposite sides are congruent. Because a rhombus has 4 congruent sides, we don't need to show that in the picture because we know all 4 sides are congruent. We know that opposite angles are also congruent. So I'm going to use arcs to show that angles that are across from each other have the same measure. Same side interior or consecutive interior angles are supplementary. Which means they add up to 180. And lastly, the diagonals bisect each other. So if I were to draw 2 diagonals in, they would bisect each other, making this segment congruent to this segment, and this segment congruent to this segment. Because a rhombus is a special parallelogram, it has 2 additional properties of its own. The diagonals are perpendicular, meaning they intersect to form right angles. So where the 2 diagonals intersect, they form right angles. And lastly, the diagonals bisect the angles. So where the diagonals meet the angles, it's cutting that big angle in half, splitting it in half, making 2 congruent angles. Moving on to example 1, we're going to draw a rhombus PQRS with diagonals that intersect at point T. If ST is 13, find SQ. So we know ST is 13. We know that the diagonals bisect each other, so ST and TQ are congruent. Since ST is 13, we know that TQ is also 13. And then to find the measure of SQ, we have 13 plus 13, which is 26, so SQ equals 26. We know the measure of angle PRS is 17 degrees. And we know that the diagonals bisect the angles, so we also know that the measure of angle PRQ is 17 degrees. They want us to find the measure of angle QRS, which is this big angle here. So to find the measure of angle QRS, we have 17 degrees plus 17 degrees, which is 34 degrees. Next, we want to find the measure of angle STR. Remember, the diagonals are perpendicular, so they intersect to form right angles. So we know that the measure of angle STR is a right angle, which means it measures 90 degrees. Next, we have that SP is 4x minus 3 and PQ is 18 plus x. We know that all 4 sides in a rhombus are congruent, so we can set these 2 expressions equal to one another to solve for x. I'm going to add x to both sides. Sorry, it's 18 plus x. I'm going to subtract x from both sides. We have 3x minus 3 equals 18. I'm going to add 3 to both sides. 3x equals 21. And then I'm going to divide by 3 on both sides, so x is equal to 7. And lastly, using the information from part D, we want to find the perimeter of the rhombus. So we're going to use the value of x, plug it in to one of the side lengths. We have 4 times 7 minus 3, which is 28 minus 3, which is 25. Because all sides are congruent, we know that all 4 sides measure 25 units. So to find our perimeter, we're going to have 25 times 4, which is 100 units. Moving on to example 2, we want to draw a rhombus ABCD with the diagonals intersecting at point E. The measure of angle ABC is 120 degrees and EC is 12. Find the following. I just want to note that the image is not drawn to scale. The image is not drawn to scale. So first, I'm just going to highlight this triangle here, triangle BEC, because that's where we're given the most information. It's going to be the most useful for us for now. So because we know that angle ABC is 120, and we know that the diagonals in a rhombus bisect the angles, we know that both angle ABE and angle CBE both measure 60 degrees. We also know that the diagonals are perpendicular, so we know that angle BEC is 90 degrees. So I can fill that in here. Because we have a 90-degree angle and a 60-degree angle, we know this is a right triangle. So our remaining angle, angle BCE, has to measure 30 degrees. So the measure of angle BCE is 30 degrees. Now we have a special right triangle, a 30, 60, 90 triangle. So to find the other sides of this triangle, we can use our special right triangle rules. 12, when they tell us that EC is 12 units, that's across from the 60-degree angle, so that's going to be our medium side. So in order for us to find our small side, which is EB, we have to divide 12 by radical 3. So we have 12 divided by radical 3. We can't leave radical 3 in the denominator, so we're going to rationalize by multiplying by radical 3 over radical 3. So we have 12 radical 3 over radical 9, which equals 12 radical 3 over 3, which equals 4 radical 3. So segment EB in this purple highlighted triangle is going to be 4 radical 3. Now that we have the small side in the triangle, we can multiply the small side by 2 to find the hypotenuse. So we have 4 radical 3 times 2, which is equal to 8 radical 3, and that's going to be the hypotenuse BC of this blue highlighted triangle. Now that is also one of the sides of the rhombus, and we know that all 4 sides in the rhombus are congruent. So AB also measures 8 radical 3, AD measures 8 radical 3, and DC measures 8 radical 3. So we know that AD measures 8 radical 3. Because EB measures 4 radical 3, and the diagonals bisect each other, we know that EB is congruent to DE. So we know DE also measures 4 radical 3. To find the measure of angle BD, so that's the entire diagonal here, we're going to add 4 radical 3 plus 4 radical 3, and we get 8 radical 3. And now they want us to look at triangle ABD and figure out which type of triangle this is. So here we know that one side of the triangle measures 8 radical 3, the other side measures 8 radical 3, and the third side also measures 8 radical 3. So this is an equilateral triangle. All 3 sides are congruent. For example 3, we want to draw a rhombus WXYZ with the diagonals intersecting at point V. If the measure of angle WYZ is 46 and VZ is 7, find the following. So here we know that the diagonals intersect to form right angles because they are perpendicular. So again, we have a right triangle, except this time we don't have a special right triangle, so we're going to have to use trig. So first, to solve for VW, if we take a look at our 46-degree angle, 7 is opposite the angle, VW is adjacent to the angle, so we're going to use tangent. So we have tan of 46 equals 7 over x. We can switch and divide here, so x equals 7 over tan 46. When we plug that in our calculator, we get 6.76. So VW is 6.76. Next, we want to find ZY. So again, 7 is opposite of 46. ZY is the hypotenuse, so we're going to use sine here. We have sine of 46 equals 7 over x. We're going to switch and divide, so x equals 7 over sine 46. And we get 9.73. So ZY is 9.73. ZY is also one of the sides of the rhombus. We know that all 4 sides in a rhombus are congruent. So to find the perimeter, we can do 9.73 times 4, and we get 38.92 units. So lastly, we're going to talk about the area of a rhombus. So we have diagonal 1 times diagonal 2 divided by 2. So for example 1, we want to find the area and the perimeter for the following rhombuses. So first we need to find the lengths of the diagonals. So here we have 30, and since the diagonals bisect each other, we know that this is also 30. Here we have 40. Again, the diagonals bisect each other, so we have 40 again. So diagonal 1 is 60 times diagonal 2, which is 80, divided by 2. That's going to be our area. So 60 times 80 divided by 2 is equal to 2,400 units squared. Or sorry, meters squared. They gave us units. Now to find the perimeter, we need to know the side lengths of the rhombus. Because the diagonals are perpendicular, we know that we have right triangles, so we can use the Pythagorean theorem to find the side lengths. So we have 30 squared plus 40 squared equals x squared. We have 900 plus 1,600 equals x squared. We have 2,500 equals x squared. We're going to take the square root of both sides, and we get x equals 50, so we know the side lengths are all 50. So to find our perimeter, we have 50 times 4, which is 200 meters.